Hello everyone, my name is Ridham Malik and you're watching Malik Robotics. In today's video, we are going to touch a very important concept in machine learning and very famous question for interviews. So this topic is confusion matrix. Without wasting much time, let's unbox this topic. So confusion matrix. So what is confusion matrix? As we all know that our machine learning pipeline has these steps. First is data collection to collect the data, or it's like to download data from Kaggle or make our own data. After that, the next step is data pre-processing to process the data according to the model requires. After that, selecting the model from the TensorFlow, Zoo, or other things, or training the model itself. And after that, we have the what we say evaluate the model, and in the evaluation of the model, if model perform bad, then we again train the model or select the new model, and if it perform good, we deploy the model. So our confusion matrix is the process of this evaluation of model part. Okay, so we already know that for regression we have various evaluation metrics like MAE mean absolute error, MSE mean square error, RMSE root mean square error, and mean absolute percentage error. But for classification we have D is like metrics accuracy, precision, recall, and F1 score. In this video we are going to talk about the evaluation metrics for classification only. Okay, so let's start. So this table which you are seeing here, it is the confusion metric. Okay, in this table we write the actual values here, like this is positive actual value and this is negative actual value, and here we make a graph in predictive value of the graph, like positive predictive value and negative predictive value. And what are this? Okay, so if our actual value is positive and our predictive value is positive, then this is true positive, means this is actual positive part. If our actual value is positive but our model predicted that it is false, then this is false negative, means it is not negative. Okay, if our actual value is negative but model predicted positive, then this is a false positive, means this is not positive. And if predicted value is negative and actual value is also negative, then this is true negative. Okay, now by using these four terms, true positive, false positive, true negative, we have derived four things: accuracy, precision, recall, and F1 score. Let's see what are these in detail. So first of all, accuracy. So accuracy simply tell us the percentage of correct prediction of a model from all the predictions. Like if these all are predictions, okay, so these are the prediction of models. From this, how many are correct? So which one are correct? Like true positive is correct and true negative is correct because these two are false. So what will the formula of accuracy? True positive plus true negative upon all. So accuracy is true positive plus true negative upon true positive plus true negative plus false positive plus false negative. So in accuracy, we just take all the values below and we calculate how much percentage are correct. Okay, so this is an important notice that accuracy is good metric only when the data set is balanced. Okay, so in the imbalanced data set, this can be misleading. How? It's just if I say there are multiple positive values and like small amount of negative value, then this accuracy metric will fall. Okay, and now for an example, if I have a spam classifier and we got 250 emails which is like spam, but there is total 300 spam emails, so accuracy is 83.3%. Okay, now precision is just from how much we predicted that this is positive, how much are actual wait I think yeah, so precision simply tell us that from predictive positive how many were actual positive. Means predictive positive are like this one and this one. Okay. So in predictive positive, how many are positive? So in this, we only tell that if our model is saying that it is positive, then what is the probability? What is the like percentage that it is actual positive? So it is TP by TP upon FP. Okay. So precision only matter when the false positive are costly. Means like there are cases like fraud detection or medical diagnosis where like if there is false positive, so we can make a chaos. Like if there's a police person and he identified a normal civilian as a thief, so he will take action which should be taken with respect to thief, but it will not be justice to that person. So that's why, so in that case we will use precision. Okay, so there is an example of precision. So let's say our model predicted there are 90 email as spam, but only 70 were truly spam. So precision work is like predicted as spam, but upon total is spam. 70 by 90 which is 78%. Only 70 were truly positive. Okay, and from the 90. Now recall. Our precision showed us that how many true positive are there in the predicted value, but our recall tell that how many were correct is like from actual corrects means in actual positive how many were correctly identified. Okay, from in precision we were saying that from the model which is saying it's positive how many were actual positive. Here we are saying that from all the actual positive how many are identified correctly. Okay, this is a similar term, but you can be confused. It's about TP by TP plus FN. Now recall matters when positive cases dangerous, like the case of fire alarm or cancers. Like here, if we give a false alarm that the person have a cancer, so he will have some other test, and it will okay. It was a false alarm, but where is the problem? Here problem is if a person have cancer and a model said that he doesn't have cancer, so that's the problem. So in these type of cases we will see the recall. Okay, now example are that has 100 actual spam mails there were, but our model only catch 70 of them, so recall is 70%. Now there is a huge misunderstanding between precision and recall, and like in many cases we don't know that we have to see precision and we have to see recall, as if in some cases if precision is going up then recall will down, and if recall is going up then precision will be going down. So we have to choose wisely that we should use precision or we should use recall. For this, let's see some cases. So this is the case one, weather forecast. In weather forecast, there is 100 days and app correctly predict rain or no rain on in 90 days. So accuracy is 90%. Why we use accuracy here? Because we don't have enough like we, we just say that how many times you were correct. We don't we need to like see that, oh, today you predicted that rain but it was not raining. So we don't need to see the precision or recall. We just see that in from the total, how many are correct. So there is only accuracy. Now, second case, credit card fraud detection. Okay, here a bank model flag transaction as fraud and not fraud. So guess what we will use here? We will use precision as if model wrongly mark too many legit payment as fraud, customer get frustrated and account get blocked and business is like lost. So if model is like say that it is fraud and it was not fraud, then it will be a chaos, and the bank will be blocked, business will be lost. So but we need to know what is fraud, but we focus on that if a person is not doing fraud, it should not be marked. So this is a precision. Okay, in this we are not using recall, because if even though we is like left someone, okay, if there is a case that there was a fraud, but our model predicted it is not fraud, then we can catch them later. It's like bank transaction, we will reverse it, and there are other methods. Okay, so in the cases where we need to is like select see how many are not fraud means or not negative, then we will use precision. But if our focus is purely we have to catch the negative part, then we will use record, like in airport security scanner for weapons. Okay, so a security scan must detect every possible threat item. Okay, if a person is going and he does not have a weapon, but our system said that he will have a weapon, then we will check him and we'll found it no, it was a false alarm, he's ready to go. But if a terrorist come and is like our model said that it's a water bottle or anything else and he have a gun, then plane is hijacked. So in this case we will use recall, where our is like consideration is that no negative part should be missed. Okay, in precision our focus is on that no person or nothing is like if it's a false alarm, then it should be very low. But in recall our focus is that there is no outlier which is left. Okay, so recall is critical. The model should flag all positive threats even if someone are false alarm. Okay, now you will say that what if I want precision and recall. Okay, so here there is a F1 score which is calculated like 2 times the precision to recall upon precision plus recall. So if precision is 78 and recall is 70%, then it is 74%. So F1 score is used when we need both precision and recall in a harmonious way. It is useful for imbalanced data, and it ensures that model doesn't just optimize on the one metric. Okay, so there are some cases where we just want that we want precision and recall both, so we use F1 score. Okay, so I think that was all about precision, recall, and accuracy. Now I think you got what are these four things. Wait. Okay. Yeah. Accuracy is how much correct. Precision. In precision, we see that there should be no false alarm. In recall, we see that there is no outlier which should be left. And F1 score is the harmonious score of precision and recall. So I hope you enjoyed this video and you like the content. So if there is any suggestion for me, then please use comment box to share to me it to me. And if you're new to the channel, just subscribe my channel, share with your friends. And until then, I think bye bye. We will meet you in next video. Bye bye.